In the previous video, I make the case that everything begins with data. In this video, I discuss what to do about it. In fact, you will have to go further than that. You will have to go beyond simply collecting random data that falls out of your systems, because you'll have to take 7 actions as part of your data strategy. The first is to design systems, whether software or hardware or appliances in the real physical environment, that will produce more data next year so that your ML models can improve over time. Let's take an example based on a customer that we've worked with and to whom we gave this strategic advice. In this example, you are a media company that needs to find the best time slot for a new TV show. To determine the best time slot for a new TV show, you need viewership data with information on age, location, and genre. Media firms tend to have this data today, and they use it to decide whether to run a show at 7 p.m. or at 10 p.m., and whether to run it only in big cities or also in rural markets. They might make decisions based on who watches the show in the same genre and where they live. For example, they may decide to run a new detective show at 10 a.m. in rural markets on a channel that is primarily watched by people in their 50s, because their historical data indicates that crime dramas do very well at that time and in that market. So this is the data the media firm has, and they're using it for traditional data analytics. Does this sound familiar? This describes many companies across a great variety of industries and how they use their data. It is used to describe the past and make data-driven decisions about the future. This works well if you're trying to decide the best time slot for a new TV show, something that you do perhaps 20 or 30 times a year, once for each new show that you produce. But machine learning is all about repeated decisions. Now imagine that you have a digital on-demand channel and you want to build a recommendation system for movies. Note the difference in scale. Instead of trying to figure out which time slot to run a show in, you're now trying to recommend movies for the next time slot open in one of your customers' lives. Thinking about it this way is important because it's about respecting the opportunity. One way to build a recommendation system is to use the data you already have. You could decide that you will recommend popular movies in the genre that the user likes. You may already have data on your existing portfolio of shows, data such as age, demographics, location, and genre. You can start with the data you have and write a set of rules. That's your traditional business intelligence method, which is building rules from descriptive data analysis. So, to build a movie recommendation system, you will find the genre that the user has watched most often. Then find the 5 most popular movies for that user demographic in that particular genre. In a digital platform, people will sign in to watch movies. So you will know which movies they've watched, and you can do this from your historical data. But notice the difference. We are no longer working with aggregate data. We need data on an individual customer's history of habits. But make sure you get permission from them to collect this data in the first place. But I started by saying that you need to respect the opportunity. You have the opportunity to provide custom movie recommendations to your customers, but instead you're giving them only the top 5 hits. Sure, the recommendations are limited to the genres that they watch. So it's comedies or romance for this user, but that's not very custom. We talked about how machine learning is a way to reach the long tail, but here we're simply reinforcing popular culture. Another issue is that you may not have enough 30 to 39-year-olds making, say, $50,000 to $100,000 in South Korea. In that case, you have to aggregate and maybe find popular movies in Asia instead. Or alternatively, you can relax the criterion on age. And as your data set grows and become more fine-grained, you can change over from business intelligence or BI and rule-based systems to machine learning. Earlier, you started with the logic, which is find the most popular movies in a genre that the user likes. Now, instead, you're starting with the data, which is given movies and their ratings across all users. And from that, you're building a model to recommend similar movies liked by similar users. The similarity in this case is learned from the overall history of movies watched and liked, and augmented by criteria such as the user's current preference and their latest movies. Notice that we don't need any concept of genre now. We don't need to pigeonhole either the users or the movies. In fact, we don't need to bucket all the users into age groups. We don't need to bucket all movies into action movies or comedies, etc. In traditional data analytics, you start with the logic and then collect data to apply that logic. You write programs to implement the logic. However, with machine learning, you start with data and then apply a standard algorithm to your data to obtain predictions. Once you identify the need to capture what movies users are watching, you can get a bit more fine-grained. How long do they watch a movie? Do they watch it in one sitting, or do they split across multiple time slots? Do they only watch the first half hour? Do they fast forward through all the action scenes or the song and dance routines? Do they add the movie to their queue but never actually watch it? At this point, you're recommending movies in the long tail, providing users with a mix of movies and maybe suggesting movies at times that the user tends to watch them. Of course, this needs to be fully automated, and the user's history needs to remain private to them. But this is the point at which you're truly respecting the opportunity. Not when you use heuristic data analytics-based rules, but when you use machine learning to provide personalized service.